The term golden ratio is frequently mentioned in various contexts. Many believe the golden ratio is connected to almost everything in the universe. But what exactly is the golden ratio, and why is it so special? This is a golden rectangle. Many believe it to be the most aesthetically pleasing and perfect quadrilateral. The ratio of its length to its width follows a specific value known as phi, which is represented mathematically as 1.618. This number is irrational, meaning its decimal expansion continues infinitely without repeating. This type of number is called a surd, amulaj sankhya. We see examples of irrational numbers like pi, which cannot be expressed as a fraction of two whole numbers. Similarly, root 2 is also an irrational number. Just like these, phi is an irrational number. The first person to observe this ratio was the ancient Greek mathematician Euclid. His name is well known because his work in geometry is still relevant today. Euclid discovered that a straight line can be divided in a special way, where the ratio of the entire line to the larger segment is equal to the ratio of the larger segment to the smaller segment. This unique proportion is phi, the golden ratio. However, at that time this discovery was not considered significant. In ancient times, mathematicians did not have the concept of decimal numbers and their infinite nature as we do today. For example, in ancient times, pi was simply considered the ratio of a circle's circumference to its diameter rather than an infinite decimal like 3.1415. The golden ratio appears in many geometric shapes. In an isosceles triangle, the ratio between its base and height follows phi. This is known as the golden triangle. If we divide a golden triangle further, we get smaller golden triangles, forming what is called the golden 9 triangle. Connecting multiple golden 9 triangles creates a pentagon, and further arrangements form a pentagram, or a 5-pointed star. If we continue placing smaller and smaller golden rectangles inside a golden rectangle and draw a curve connecting their corners, we get the famous golden spiral. One fascinating property of phi is its unique mathematical relationships. If you multiply phi by itself, the result is phi plus 1. If you divide 1 by phi, the result is phi minus 1. The golden ratio gained even more importance through the Fibonacci sequence, which is a series of numbers where each term is the sum of the two previous terms. 1, 2, 3, 5, 8, 13, 21, and so on. As you divide each Fibonacci number by its previous one, the ratio gets closer and closer to phi, approximately 1.618. This sequence was introduced to Europe by the Italian mathematician Leonardo Fibonacci, who played a key role in popularizing the Hindu-Arabic numeral system. He included this sequence in his book Liber Abaci, which taught how to use modern numbers for calculations. Despite its fascinating properties, many misinterpret or overstate the golden ratio's presence. Some claim that DNA structures, human body proportions, and famous architectural designs follow the golden ratio, but these claims are often exaggerated or incorrect. Just because something approximates phi does not mean it was intentionally designed with it. Thus, not everything follows the golden ratio, and it is important to differentiate scientific facts from myths. The golden ratio is undoubtedly a fascinating concept in mathematics and geometry. While it appears in many natural and man-made structures, its presence is not universal. The relationship between the Fibonacci sequence and the golden ratio remains one of the most beautiful mathematical discoveries.